In the dark silence of space, a mirror unfolds, but it doesn't reflect us. It reflects what once was. Galaxies born before our sun existed. Light so old, it has traveled 13 billion years to be seen by us now. This is the James Webb Space Telescope, and this is what it sees. Its very first image, a deep field of ancient light, was aimed at a tiny, empty patch of sky, a point no larger than a grain of sand held at arm's length. From Earth, it looked like nothing, but to Webb, that emptiness was overflowing. Thousands of galaxies emerged in that single image, some spiral, some chaotic, some so red-shifted they appear stretched and ghost-like. Many of these galaxies were formed less than a billion years after the Big Bang, cosmic toddlers in the timeline of existence. That image alone, known as Webb's first deep field, changed how we think about what's out there and how much we've been missing. Because Webb doesn't just look farther, it sees deeper. Unlike Hubble, which mostly sees visible and ultraviolet light, James Webb sees in infrared. And infrared light behaves like memory. The older it is, the more it stretches. As the universe expands, light from ancient stars is pulled into longer wavelengths, slipping out of human sight. But Webb is built for that. Its massive golden mirror, composed of 18 hexagonal segments, is tuned to detect light invisible to us. Light that began its journey billions of years ago. In some cases, long before Earth had oceans, trees, or breath. So when Webb looks, it's not watching the present. It's watching the aftermath of beginnings, remnants of galaxies just learning how to shine. And this is only the beginning. Astronomers used Webb to study a galaxy called JWST 13-0. Its light left the galaxy over 13.4 billion years ago, making it one of the earliest galaxies ever detected. Before this, we thought such complex galaxies didn't exist that early, but there it was, clear and present in Webb's field of view. It's like finding a photograph of a newborn already walking. Each image Webb sends back brings questions, not answers. Why are some galaxies fully formed so early? What made stars ignite so quickly? How can something so far away look so familiar? Webb doesn't explain these things. It only shows them in silence. And sometimes, that's all it needs to do. For in that silence, we begin to ask better questions. We begin to wonder not only what the universe is, but when it became what it is now. James Webb doesn't capture what is. It captures what was. When you look at its images, you're not seeing the universe as it exists today. You're seeing how it looked billions of years ago, frozen in the moment light began its journey. That's the strange truth of astronomy. The farther you look, the further back in time you go. And James Webb is the most powerful time machine we've ever built. In one image, you may be looking at a spiral galaxy so far away. Its light left when Earth had no life, not even single-celled organisms. In another, a cluster of galaxies bending the light behind them, revealing even more hidden structures in the deep. These distortions aren't glitches. They're real, and they're beautiful. It's called gravitational lensing. When massive objects like galaxy clusters sit between Webb and something even farther away, their gravity bends and magnifies the light behind them. Webb captures this curved light and pulls into focus galaxies we would otherwise never see. Some of these faint arcs are from the earliest days of the universe, distant, fragile things, stretched by time and space. But Webb doesn't stop with galaxies. It also peers into star nurseries, regions of dust and gas where stars are born. The Carina Nebula, the pillars of creation, places Hubble once revealed in color and drama, are now shown in deeper clarity. Webb sees past the dust into the warm, invisible light where stars are forming. It shows us what's usually hidden. In these nurseries, stars are being born, shaping the very fabric of what will become planets, moons, oceans, and perhaps even life. And somewhere, among the billions of stars in our galaxy, and the trillions in others, there may be worlds that look toward us, wondering if they too are alone. That's the quiet question behind Webb's exoplanet work. It doesn't just observe distant stars, it studies their planets. By analyzing how starlight filters through a planet's atmosphere during a transit, Webb can detect its chemical makeup. In one of its first tests, Webb identified water vapor in the atmosphere of a planet over 1,100 light-years away, a gas giant called WASP 96b. Water, not oceans, not rain, but the basic element of life as we know it. And this is just the start. Webb is scheduled to study smaller, rocky planets, ones more like Earth, and search their skies for methane, carbon dioxide, and other signs of habitability. It will not tell us if we are alone, but it will narrow the space in which that question remains unanswered. And perhaps that's enough, because sometimes just knowing where to look and having the patience to wait for the light is the beginning of discovery. The more James Webb sees, the less we seem to know. That's the paradox of clarity. We thought the early universe would look chaotic, small, scattered galaxies still forming, still finding structure. But what Webb found instead were massive, mature galaxies, far too early, far too formed. One of them, star 1749, appears to have existed just 700 million years after the Big Bang, and yet it's shaped like something billions of years old, ordered, bright, stable. This shouldn't be possible, not according to the models we've trusted for decades. And yet, there it is, plain in Webb's vision, quietly challenging everything we thought we knew. Astronomers are revisiting old assumptions. Was galaxy formation faster than we believed? Or are our ideas about the early universe missing something? The telescope doesn't answer these questions. It doesn't argue. It simply shows. And in doing so, it reveals how much of our cosmic understanding may be built on shadows, waiting to be undone by the next wave of light. This is why Webb feels different. Not just powerful, but humbling. Because it doesn't just study stars, it studies beginnings, and in doing so, it brushes up against our deepest questions. Where did it all begin? Why does the universe look the way it does? And how much are we still not seeing? Webb peers into what's called cosmic dawn, the time when the very first stars ignited, ending the universe's dark ages. This era, just a few 100 million years after the Big Bang, is invisible to ordinary telescopes. The light is too faint, too stretched, too old. But for Webb, it's a window, a narrow, glowing crack in the dark that might show us the first time atoms formed galaxies, the first time hydrogen sparked into fusion, the first time anything shined. To witness those moments is to stand at the edge of the knowable. And while most of us will never see these images firsthand, never sit at the control room or decode redshift, that doesn't mean we're not part of the story. Because each discovery Webb makes quietly reshapes the story we all live inside. It stretches our imagination. It redefines how far is. It softens the edge between wonder and truth. And all of this, from a silent mirror floating 1 million miles from Earth. 1 million miles from Earth, orbiting a point of stillness in space. The James Webb Space Telescope does something almost unthinkable. It waits. No engines, no roaring data centers, no blinking control panels in a science fiction lab. Just silence and light, ancient light, still arriving. It takes 13 billion years for a galaxy's glow to reach us, but it only takes a few seconds for that image to stir something in us. A sense of scale we can't fully grasp, a kind of awe that doesn't need to be explained, a feeling that we are small, not in a way that diminishes us, but in a way that expands everything else. James Webb doesn't demand our attention. It doesn't broadcast noise. It simply watches, and what it sees reshapes the way we think about our place in the universe. When we look at its images, we're not looking at stars. We're looking at memory. We're looking at the aftermath of explosions, the birth of light, the gentle spirals of matter assembling itself into something coherent. We're looking at things that no longer exist, and yet, because of distance and time, they still shine. This is the strange comfort of astronomy. It reminds us that beauty is not fleeting, even if it comes from the past. It also reminds us that what we are is rare. The more space Webb surveys, the more we realize most of the universe is empty, not just silent, but barren, cold, without form. Galaxies are islands, stars are brief, and planets like ours, warm, vibrant, balanced, might be even rarer than we thought. And yet, here we are, able to build a mirror, able to send it into the sky, able to understand what it tells us. This is not just a triumph of engineering. It's a quiet celebration of curiosity. And even though the telescope itself will never know us, will never feel pride or purpose, it continues to gather light, piece by piece, from the very edge of time, so we can see, so we can ask, so we can wonder. And maybe that's what makes it beautiful, not just what it sees, but the fact that we chose to build it in the first place. In a universe filled with silence, we made something that listens. In a universe ruled by chaos, we built something that finds pattern. In the great, unknowable dark, we placed a mirror. And in that mirror, we don't see our faces. We see everything else.